Alright, we're going to look at how to decode the station models a little closer. I'm in Blackboard, clicked on week by week already, so here's your week 1, week 2. I'm going to go into the weather websites folder, and in here there's all these different websites you can use that are very helpful, very good ones. And the one I'm going to click on is the RAP real-time weather, and I like this one as well as all the stuff from the AMS. It has the satellite surface forecast, everything kind of in one little spot as well. If you want to look at a bunch of station models, here's another way you can actually get to them, and it shows all of them in the Midwest, or you can choose obviously whichever region you're looking for. Now the whole purpose of why I was wanting to get on here is because, let me go back to their main page, it has what's called help pages. Under the help pages, it'll help you read any one of these maps. So it's another resource to use to help you look at weather maps and understand them. If you click on the surface one, then it gives you a surface observation, and it tells you all the details that you need to know about, why it's colored, why it's not, all that kind of stuff. So it's kind of nice. I like that. So if you're looking at the one they have as their example, the temperature, and you'll find that all surface maps in the United States are done in the units that you're used to, like the Fahrenheit, and you'll see on TV they'll do the inches of mercury and that kind of thing. So you'll find that the surface ones will have a little bit more familiar units. When you use anything that's above, like going above the surface, so the 850, then 750, 700, any of those levels, then everything's going to be in more standardized units that everybody else in the world uses, except for us. So here is the station model. The number here is the temperature, then right underneath it's the dew point, and between the two numbers, if there's weather going on, that's where you'll find other additional information. If there's no other weather happening, then they're not going to have anything listed. So in this case, this little symbol is a thunderstorm, and it tells you all the symbols. There's another, scroll down a little bit. This little portion next to, if there's any weather listed, is the visibility. The visibility is done in miles. And it'll tell you, you can see far ahead of you, however much. If it's more than 10 miles, so if you can see at least 10 miles ahead of you, it won't be listed. Even if it's usually, you'll see even if you have 7 to 9 mile visibility, it probably won't be listed as well. But typically if you have any visibility issues, you're not going to go from 7 to 10 isn't going to be that big of a change. They're obviously going to really start listing stuff more if it's, you can only see about 5 miles in front of you. So you only see that, of course, if there's some kind of weather going on and there's fog or rain, precipitation, snow, things like that. The little circle tells you the cloud coverage. If it's just a little square, and you can see down here cloud coverage symbols. If it's a square, it's clear skies, and that's usually indicating that it's clear below 12,000 feet. So it's possible there's really high thin clouds, but it's not registering on what they call the ASOS weather machines that actually send up beams into the atmosphere to kind of pick up whether there's clouds or not. So it's possible it's clear skies, it's indicating clear skies, but you look up there and like, well, I see some clouds. That could be the issue. And you can see the differing of how much of it's shaded in, tells you how much of the sky is actually covered and that kind of thing. The different colors, and each website might have something different for the colors, but of course in this one, you can see over here if it has a color to it, then especially if it's red, tells you that IFR rules apply, and that's more for people flying. So any kind of pilot's going to want to know if you have visual flight rules, which means that you don't have to rely on your instruments. You can see far enough ahead of you that you're okay. Instrument flight rules would mean that there's something going on and you're not going to be able to see with your own eyes. You're going to have to use your instruments to tell you, where you're going and what you're doing. So that's the different color coding for them. There's a whole bunch of other stuff that could be around here, but typically you don't see that anymore with all the new data and the way you can post it on the web and put it in certain files and that kind of thing. Back in the olden days, this whole thing around here would be just filled with lots of great information. But now that we have this ability to put everything on the web and store things in a better format and have everything separate but still easily accessible, and then of course generate weather maps and not have to have these little station models as our only way of looking at what's going on across the world and the country, that they're a lot more simple now. So you'll typically just see temperature, dew point, if there's any weather going on, tell you the cloud coverage, it'll be the wind information, and you'll see the pressure. And in this case it's listed as the altimeter, which is when you're using the millibars. So this is the pressure in millibars. So how you decode that is pretty easy. It takes a little bit of getting used to. So you have this 3-digit number. You always move the decimal place one place to the left, so that would make it 00.5. And then you have to decide, do I add a 9 in front of that, or do I add a 10? Meaning, would it be 900.5, or would it be 1000.5? And the way you look at it is you try to keep the pressure somewhere between 950 and 1050. 950 would be very low pressure, and 1050 would be extremely high pressure. So an average somewhere in between. And unless something's going on, you can always use that as a good guideline. So if you were to add a 9 in front of it, it'd be 900.5, which obviously doesn't work because that's lower than the 950. So you would have to go with the 1000.5 would be the pressure. So that's kind of how you read it. The wind barbs on this, you can see the wind barb comes down off, basically off the back end of it, or the bottom part of it. And you read this like a compass, so up and down would be north, east, south, west. So in this case, going straight down is south. It's slightly over to the right, so you might call it maybe a south-southeast wind. A lot of times on a lot of maps you'll see, especially text maps, it'll give you the actual degrees. So it'll be a little bit more precise. Instead of saying south-southeast, here it's 170 degree wind. Now the wind speed is the lines that come off of it. So a long one is 10 knots. A short one, so it'd be half the size of this, would be 5 knots. So and every time you add a wind barb off here, then you have to add it up. So if there was more than one, there's 2 of these long lines, it would be 20 knots. If there's 3 of these long lines, it would be 30 knots. If you had 1 long line and a half a line, it would be 15 knots. That would be the idea. They use knots. It's a little bit more, of course, a little bit more standard unit and a little bit easier to use for wind because it's a measurement for the wind specifically. And 1 knot equals about 1.14 miles per hour. So they're pretty much, when you're talking about smaller speeds, the equivalent is, pretty much the same. So 10 knots, in your mind, you can kind of think of it as 10 miles per hour, unless you needed to know the exact changeover. You actually had to convert it for some kind of forecast model, or something where you wanted the exact number. Otherwise, when you're looking at it, you can kind of gauge in your mind a little bit that they're pretty similar. They're not too much of a difference. So when I'm looking at this, thinking at 10 knot wind, okay, now in my mind I'm going to imagine what a 10 mile per hour wind is like, and that's going to give me a good idea in my head that this is what's happening with the wind. So this is a good resource to help you read any of these station models. I'm going to flip back to the actual surface model portion, so that way we can look at one of these. And I'm just going to pick Emporia, Kansas, because it's kind of out and away from everything. It's a little easier to see. 28's number on top is the temperature. Number on bottom is 4, which is dew point. The further those two numbers are apart, the drier the air is. There's no other weather going on. There's, not snowing, not foggy, hazy, anything like that. So there's nothing else listed. There's no visibility issues. The wind is coming out of the east. So the wind is coming from the east at 15 knots. Long line, short line. Your pressure looks like it's 264, so that would be 1026.4 would be the pressure. Because if you used a 9, it would be 926.4, and that doesn't fit between our range of 950 and 1050. So that's why it's 1026.4. So if you have any other questions on how this works, then let me know.